Shared key authentication uses a shared secret such as the web key to authenticate the client. The information exchange is illustrated in this presentation. The wireless client first sends an authentication request to the access point, which responds back with a challenge. The client now needs to encrypt this challenge with the shared key and send it back to the access point. The access point decrypts this to check if it can recover the original text. If the decryption succeeds, the client will be authenticated. In case of a failure, an authentication failed message is sent to the client. The problem here is that an attacker passively listening to the entire communication has access to both the plain text challenge and the encryption challenge. He can apply an XOR, also known as exclusive OR operation, to retrieve the key stream. This key stream can be used to encrypt any future challenge sent by the access point without needing to know the actual key. In this video, we will see how to sniff the air to retrieve the challenge and the encryption challenge, save the key stream, and use it to authenticate to the access point without needing the shared key. We will start by accessing our wireless security settings of the router's admin interface and enable web or wired equivalent privacy. We will use the key 1 as the default transmit key, so you need to provide that key. You can enter anything here as we will not decrypt the key in this video. In my case, I will enter ABCD 1, 2, 3, 4, 5, 6. Then we'll save and apply the settings. And now the fun part. I will open a PuTTY window which is already connected to my Kali Linux machine. Make sure that your wireless adapter is in monitor mode by issuing airmon-ng command. Next, let's obtain a list of available networks in our area by using aerodump-ng followed by our mon0 interface. The network that we are interested in is Wireless Lab. To obtain more information about this network, we then use the aerodump-ng command followed by our mon0 interface, the -c parameter which specifies the channel used, in our case 6, --BSSID which specifies the MAC address of the access point, and finally we want to store the packets in a file prefixed with the shared key word, so we specify that by using the -w option. By using this option, we will be able to save the key stream in a file that starts with the shared key word. So let's start the application, and right now the out column is empty. Also, no client is connected to the access point. Let me connect my phone to the access point as a legitimate client, and as soon as I connect it, the out column will say SKA, which stands for Shared Key Authentication. As soon as we see this in the out column, you can exit the application. Now, some things to keep in mind too. It might be that even if a client is connected to the access point, you will not be able to see the SKA appearing in the out column, or it might be that no XOR file has been saved. Some routers are protected against this type of attack. This is the reason why I specifically use this custom firmware with this router and not the original firmware. The original firmware appears to protect the router against this type of attacks, so in case you're not successful with this attack, this could be the cause. Now let's display a list of current files by using the ls-a command. We can see a file called shared key having the XOR extension. This is the file that we're interested in. This file contains our captured key stream. In case you don't obtain this file, it might be that the router is protected against this type of attacks. Anyway, it's worth trying a couple of times before giving up. Next, let me switch to my router's interface and we'll go to status and then to wireless in order to see the currently connected wireless clients. Right now, the only connected client is my phone. Let's get back to the PuTTY window while leaving the router's interface in the background. In order to fake a shared key authentication, we will use the airreplay-ng tool. We specify the one option which represents the fake authentication type of attack. Next we put 0, which specifies the reassociation timing in seconds. Then we provide our wireless LAP network by using the -E option. Next, we instruct the mReplay tool to use our keystream file by using the -Y option, followed by our shared key file that has the XOR extension. Then we provide the MAC address of the access point by using the -A option and an arbitrary MAC address representing the client. We will use AA 6 times as the arbitrary MAC address so we can easily identify it later. And finally, we specify the interface that we use, which in our case is the MON0 interface. Now if I press enter, we receive an error saying that it couldn't determine the current channel for MON0. In order to solve this problem, we use the specified solution. Add ignore -1 at the end of the command. So we run the previous command one more time and we add ignore -1 at the end of it. And now please watch the connected clients list as I press enter to run the command. We can see that a new client having the arbitrary MAC address that we specified is now connected to the access point. And back to the PuTTY window, we can see the steps that I described at the beginning of the video. The client sends an authentication request to the access point. This one replaces with an encrypted challenge, and in our case, the client sets back the correct encrypted challenge. The access point accepted, and the client is now connected to the access point by using fake authentication. So this is how we can connect to the access point without even knowing the shared key. Thanks for watching.